Hi, welcome back to our fifth video for 4.1 special angles. In this video, I'm going to show you how to find the trig ratios for 0, 90, 180, and 270. In fact, I'm actually going to show you how to find the trig ratios for any angle. So to do this, we're going to use the unit circle. So I'm first going to draw it out. And I'm probably not going to make the best circle, but that's okay. This is X, this is Y. You guys get the idea. And it's a unit circle, meaning the radius is only 1. So I'm going to try to kind of draw through here as neatly as I can. So that is my circle, okay? So it's not my greatest work, but anyway. Um, so the unit circle, this is how we use it. We first draw the initial arm, right? That's called the initial arm. And from that, we draw any angle to our terminal arm. I'm going to make the terminal arm in green, let's say. Okay. So if the terminal arm ends up here, then this measure, that's the angle in standard position. Okay, this is all stuff that I kind of had explained in the first video in the investigation. This other angle here, the acute angle that is made with the x-axis from the terminal arm, it's always acute, less than 90. It's not this big one. Okay, that's the angle in standard position. This one is called the reference angle. So you can always use the reference angle to find your trig ratios, especially if you know the kind of triangle that's here. So if you knew this was 30, that's great. You could draw that 30-60 triangle that we had did up here. And you could use these trig ratios. Just pay attention to the sign. But anyway, the point up here, this is what I'm trying to get at. If you draw this unit circle nicely, your ordered pair, we're going to call this theta. That's the angle in standard position. So this point on the unit circle, if I call it point A, the x value is going to be cos of theta, and the y value will be sine of theta. That's how it always works out with the unit circle. Okay. The reason why it works out like that is because it's a unit circle and the hypotenuse has a value of 1. So then when we try to find the rest of the triangle, if we were to, let's say, do cos of this angle, well, it's going to be the adjacent x over 1. So cos is equal to x over 1. So we can see that cos is exactly x. Same with sine as well. This actually makes a little bit more sense if I even draw it on the other side. So I'm going to erase this for now, and I'm going to draw it on the other side. So let's draw the terminal arm. Let's draw it up here. Actually, I'm going to use green. We'll draw it right here. Okay, we're going to move theta over inside. Okay, and this is our initial arm. Okay, so we have our initial arm, we have our terminal arm, we have the angle in standard position. When the angle in standard position is less than 90, you don't need to worry about a reference angle. So now, when I look at this triangle here, okay, I'm just going to redraw it up here. We're going to have theta. Remember, this is a unit circle, right? So the length of this is 1. So that means the length of this triangle is also 1. So I'm going to put a 1 here. We also have 90 degrees there. If I write out an expression for cos theta is going to be the adjacent, which is this length, over 1. Well, what is the length of this triangle here? This right angle triangle? Well, let me redraw this here. This is the triangle up here, right? So the length of this is just going to be x for the ordered pair up here, xy, right? This point, the x value is going to be the base of the triangle. The y value is going to be the height of the triangle. So, well, what's cos theta? It's going to be x over 1. So it's x over 1 is just x. So we can see that cos theta equals x. So the x value for this point on the terminal arm is cos theta. What's the y value? Well, we said it's the height of this triangle right here. I'm going to call it y. If I write out sine theta, I'm supposed to do opposite, which is y, over the hypotenuse, 1. So y over 1. So that means sine theta is actually just equal to y. So it tells me that this ordered pair, the x is cos theta and the y is sine theta, like I wrote up here. Okay. So that's what the unit circle is good for. Okay. Now let's go ahead and let's do it for 0, 90, 180, and 270. So I'm just going to draw a new one here. And we'll just use the same unit circle to do all of them. So x, y, and we'll mark off 1 up here, 1 there, -1 there, and -1 there. That's a little far. That last one will go about right here. Okay, that's looking a little better so far. All right, so there's my unit circle. Okay, now it wanted us to find the primary trig ratios. So that means all 3 for these 4 angles. Okay, so I'm going to create a table to do this. So we'll do cos. Let's start, we'll do cos. We'll do sine. And then we'll do tan. Here we'll put in our angle. We'll say 0, 90, 180, and I think the last one was 270. Yeah. Okay, so these are the angles that I got to draw the terminal arm at. So I'm going to do this one. I'll do this one in red. So at 0 degrees, that means my arm is right here, and my point is right here. This ordered pair is 1, 0. So remember, the x is cos of the angle, and the y value is sine of the angle. So if cos theta is 1, so the angle is 0, so cos of 0 must be 1, and sine of 0 must be 0. Okay, because theta, I wrote theta here, but remember the angle is just 0, so these are, if you want, I can actually just write in 0 for those. Cos 0 and sine 0. Okay. Let's do the next one in pink. So what if our arm was at 90 up here? Well, what's this ordered pair? Well, it's 0, 1. Well, the 0 represents cos of 90, and the y value is sine of 90. So cos of 90 is 0, sine of 90 is positive 1. We're going to do the tans last. Okay, moving over in green, we can do 180. That would be out here. So my arm would literally rotate all the way 180. Okay, what's this ordered pair? Well, it's -1, 0. The x value is cos of 180. The y value is sine of 180. I think you guys are probably getting the idea now, if you haven't yet. So cos of 180 is -1. Sine of 180 is 0. Okay, and our very last one down here on the bottom, this is a rotation of 270 all the way to there. That has an order pair 0, -1. 0 is cos of 270. negative 1 is sine of 270. Okay, the cos of 270 is 0, and sine of 270 is negative 1. Now, to figure out the value for tan, remember it's actually just the slope of the terminal arm. So this has a slope, the red one, at 0 degrees has a slope of 0. Okay, also what you can do to find tan for a shortcut, tan of theta, whatever angle it is, it's going to be the y value divided by the x value. It's a shortcut. So if you do 0 divided by 1, you get 0. So you can also do, which means the same thing, you can do sine theta over cos theta. So to get tan, you can just do the sine value divided by the cos value. That's a quick way to do it. I'm going to do that to fill out the rest of these. So 90 degrees. So sine is 1, cos is 0. 1 over 0, that's undefined. Let's take a look at the unit circle. What's the slope of this vertical line? Well, the slope of a vertical line is undefined. Moving on to 180. What's the slope of this line? Well, it's just 0. Okay, how can I tell? We'll do sine over cos. 0 over negative 1 is 0. And tan of 270, our last one. Okay, what's the slope of this line? Well, it's vertical, it's undefined. Also, if you try to do negative 1 divided by 0, also undefined. Okay, let's check some of these at the calculator. Let's do cos of 270. 0, and that's right. Okay, let's try tan of 270. Undefined. Okay, we'll try one more. Cos of 90. We should get 0, and we do. So that shows you some of the power of the unit circle. So it's hard to find the trig ratios when your point is like somewhere over here. But if it works out to fall on the x and y axis, it's real easy to get the ordered pairs. And once you get the ordered pair, it's real easy to find cos or sine of the angle. Okay, that's it for this example. We have one more left, so I'll see you guys in the next video.